Hi everyone, I am Dr. Kiran, working as an assistant professor in the Department of Electronics and Communication Engineering, MLR Institute of Technology, Hyderabad, India. So, in the previous session, we have discussed about the basics of electronic devices and circuits, what are the importance of electronics, and then corresponding components we have discussed like PN junction diode, what is p-type and what is n-type material, and how PN junction is generated, and what is the VI characteristics, that is voltage and current characteristics of the PN diode we have seen. So from that, in continuation to that topic, today we are going to talk about resistance and current components of the PN diode. So let's have a quick view on this. So today we are going to cover the following topics. From the beginning of VI characteristics, we start the characteristics of volt, ampere, and then we will start resistance of the PN diode. Then we will continue with the current components of the PN diode, then current equation, and then conclude with summary. So let's get into the topics. So we have studied in the previous session that VI characteristics of the diode. So depending on the different biasing concepts. So what is zero bias? Zero bias means we are not applying any external voltage to the diode. In such case, so the depletion width will be increased. In forward bias, so there is a current flow in the diode. So in such case, if you further increase the forward bias voltage, then the current will be increased and also the depletion width will be reduced. So as depletion width is reduced, so you can check here, this is your VI characteristics. So this is your forward bias. So in forward bias condition, the moment you apply in the forward bias voltage, this is forward bias voltage. So the moment you apply the forward bias voltage to the diode, so this is your construction of forward bias diode. Okay. Now the moment you apply the forward bias voltage, the current does not start conducting through the diode because it requires some voltage which should be exceeds the barrier potential. Here you will have barrier potential. So under zero bias, there will be a barrier potential in the junction, at the junction. So therefore, in order to make the diode conduction, you require some external amount of voltage which should be more than this barrier voltage or barrier potential. So once the applied voltage is greater than this barrier voltage, then the diode starts conducting. The moment it exceeds the barrier potential, so this voltage is nothing but cut-in voltage or barrier voltage. So cut-in voltage or knee voltage, it is also called as knee voltage. So what do you mean by knee voltage? Knee voltage is the voltage from which the diode starts conducting, and after that the diode current will increases drastically. So here this characteristics is non-linear. The diode characteristics is non-linear. So what do you mean by linear? Linear means what? So here, so we are applying input voltage and correspondingly we are measuring current through the diode. So linear means what? So the moment you apply the voltage, for example 0.1 volts, the current will be, for example, 0.1 milliamperes. 0.2 volts for 0.2 volts, the current will be 0.2 milliamperes, and so on. So if you consider this, the current is linearly related to the input voltage, applied voltage. So this is called linear, but this is general case, no bias case, no bias, zero bias case or no bias case. Whenever you apply the input voltage or applied voltage, then the current starts from cut-in voltage. This is the cut-in voltage, 0.7 volts for silicon. This we have already discussed in the previous session. Okay. So, from this, in reverse bias, what happens? In reverse bias, you can say, so in reverse bias, the depletion width will be increases. So, in such case, what happens? As the depletion width is increases, there is no current flow in reverse bias. So, that means in reverse bias, the diode offers large resistance. Large resistance. I said large resistance means zero current or no current ideally. But practically there is some current which is called reverse saturation current I0. Okay. So, today we are going to study about what is the resistance. How we can measure the resistance from the VI characteristics. Let's see. So, resistance of the diode. So, we have two types of diodes. So, for forward bias junction, we have two different kinds of resistances, that is static forward resistance and dynamic forward resistance. In the same way, we have reverse resistance of the diode, that is reverse static resistance and reverse dynamic resistance. So, what are these? Let's see. Forward resistance of the diode. So, forward resistance of the diode means when diode is connected in forward bias. So, when diode is connected in forward bias, what is the characteristics between voltage and current? It is a non-linear characteristics. We can also call it as this is piecewise linear. This is called piecewise linear characteristics. Okay. So, in this case, static forward resistance means when the diode is supplied by a DC source. When the diode is supplied by a DC source, then the resistance offered by the diode is called static forward resistance. So, it is given by RF is equals to forward DC voltage upon forward DC current. So, that is V by I. Simply directly we can write V by I. So, the slope of this curve will be linear, that is slope is same throughout the curve. So, slope is linear. So, therefore, simply we can write wherever you consider any point throughout the curve, the slope will be linear. Okay. So, therefore, the resistance RF is given by voltage upon current directly. So, when DC circuit, that means it is used in DC circuits. Forward resistance means DC circuit. So, when DC supply is given to the diode, then the resistance offered by the diode is called static forward resistance given by RF. Similarly, dynamics forward resistance. So, it is used in the AC condition. That means the diode is supplied by AC voltage, AC source. Then the resistance offered by the diode is called dynamic forward resistance. Dynamic forward resistance. In such case, so you may not get, that means, what do you mean by dynamic means AC? So, AC means here, in the first case, we are giving DC source to the diode. So, in second case, we are giving AC source. So, in such case, obviously there is a fluctuation in the voltage and current. So, input voltage and correspondingly current also changes. So, therefore, the slope is not linear. In this case, the slope may be changes accordingly. So, therefore, in this case, we can say RF is 1 upon slope of forward characteristics. That means delta VF by delta IF. That means, see here, so this is your cut-in voltage. Okay. So, consider any two particular points. On this curve. So, this is V1, V2. This is I2, I1, I1, I2. So this is called delta F, delta I. Delta I means IF, you can say forward current. This is the change in the voltage, applied voltage, delta VF. So this is VF and this is IF. On x-axis we take voltage, forward voltage, on y-axis we take forward current. So therefore now coming to the RF. So RF is given by change in voltage, that is change in delta VF by delta IF. That means V2 minus V1 by I2 minus I1. So which can be obtained from this VI characteristics of the diode. So this way we can able to calculate the forward resistance of the diode, that is static resistance and dynamic resistance of the diode. Now let's come to the reverse resistance. Reverse resistance of the diode means what? So reverse static resistance, it is also same, but in reverse bias condition. So when diode is connected in reverse bias condition, the resistance offered by the diode when it is supplied by a DC source, when it is supplied by DC source, the diode offered, the resistance offered by the diode given by RR is equal to reverse DC voltage and reverse DC current, VR by VF. So when it is connected in reverse bias condition, what happens? So this is your characteristics. So this is VF and this is IF, but we are talking about reverse bias condition, right? So therefore this is minus, you can say IR. IR on x-axis you have VR. That means reverse voltage, reverse current, corresponding reverse current. So the change in the reverse current according to the applied reverse voltage in reverse bias condition. So this current is called I0, reverse saturation current. This we have discussed in the previous session, I0. I0 is the reverse saturation current. So therefore, how we can calculate this is same way. The same way you can calculate. So consider any two particular points, okay, and these 2 points. So this one, this is the delta I and this is delta V, delta VR, delta IR. So here delta VR by delta IR gives you that means what? This is V2 minus V1 by I2 minus I1 in reverse bias condition. Okay, so the change in the output current through the diode for the applied AC signal. Okay, so this is about forward resistance and reverse resistance of the diode. So next topic is we have current components to the diode. So what are the current components we have in the diode? The total current can be, so the current is diffused. So whenever a supply voltage is given, sometimes your electrons and holes will diffuse from one side to another side. So let us see here. So this is a PN diode, P type and N type semiconductor material, and this is the depletion region. Now, so whenever any supply is given, for example forward, so what happens here? So some of the electrons or the majority charge carriers in this will be diffused towards the P side. Similarly, some of the holes or majority charge carriers will diffuse towards this. So majority charge carriers holes from P side will diffuse from P side to N side, and majority charge carriers electrons will diffuse from E to N side. Okay, so these components. So due to this, there are some current flowing through the diode. So total current will be IPN of x plus INP of x. X means what? This is the center point. This is x is equal to 0. So, whenever the holes from P side will diffuse towards N side, so in such case the concentration of that holes will reduce exponentially. So, let me draw another one, how it look like. So, this is your x is equal to 0 point at the junction. This is the barrier junction. So, from this holes will move towards the N side. So, these concentration will be decreases. The electron concentration on N side will be decreases exponentially like this. Similarly, holes also will diffuse from N side to P side, and their concentration will be decreases like this, as considered to the with respect to x. So, therefore, what is this PN? PN means what? The current due to holes in N side. N side holes will be diffused, no? So, due to that some current will flow. So, because of that, so this is the current. IPN means what? Current due to holes in N side as a function of x. And INP is the current due to electrons in P side as a function of x. So, therefore, total current at x is equal to 0, the current is given by IPN of 0 plus INP of 0. So, I is equal to IPP of x plus INP of x on P side. So, P means what? IPP means what? This is the whole current in the P side. This is the electron current in P side, on P side I said. So, this indicates P side. So, this is hole, this is electron. Here also INN. INN means N is electron. So, current due to electron in N side, current due to holes in N side. So, these are the different current components we must know while calculating what is the current flowing through the diode. Okay. So, I will stop for today. So, we will continue in the next session. Thank you.